Let's take a look at composite figures. So we're looking at figures that are made up of more than one shape is what we're doing. So this first one, find the volume of the composite figure, round your answer to the nearest tenth, use 3.14 for pi. So you'll notice I've got like an ice cream cone here. So I've got half sphere on top and then a cone on the bottom. So I'm going to break this up into my sphere and my cone. So I'm going to use those two different formulas. So for my sphere is volume equals 3/4 pi r cubed. So notice here they've got from the center of the top of this cone out is my radius. So I've got the volume equals 4/3 pi. I'm going to do 2 cubed. So I'm going to grab my calculator here. Volume equals 4/3 pi, and then 2 cubed is 8. I'm just going to grab my calculator here, and I'm going to do 8 times, and they told me to use 3.14. So I'm coming up with 25.12. And then my 4/3, I'm going to do times 4, and then I'm going to do divided by 3. And if you are comfortable with your fraction keys on your calculator, feel free to use that. We're rounding to the nearest tenth here, so I'm going to come up with 33.5 because I'm coming up with 33.49333. But remember that this is only half of that, so I'm also going to divide by 2. So the volume of half of that is going to be, I'm coming up with 16.7. So there's my half sphere. Then I want my cone, and the formula for my cone is V equals 1/3 the base times the height. 1/3 the base times height. And remember, my base is that circle there, so my pi r squared. So V equals 1/3 pi r squared times the height. V equals 1/3 pi. My radius is still 2, and my height in this case is 4. So I'm going to do V equals 1/3 pi, and that's times 8. So I'm going to grab my calculator. I'm going to do 8 times 3.14 because that's what they told me to use for pi. I'm going to divide that by 3, and I get 8.37. So I'm going to call that 8.4. So I've got the volume of the cone, volume of the half sphere. I'm going to add those together. So if I get 8.4 plus 16.7, I'm coming up with 25.1 inches. And again, I would fill this with cubes, so inches cubed. So again, we're doing two pieces here. We're finding the volume of each of the parts and then adding them together. All right, let's take a look at the second one. A hemisphere is 1/2 a sphere. The top of a silo is a hemisphere with a radius of 12 feet. What is the volume of the silo? All right, so we've got a hemisphere, or half of that sphere. So I'm going to need my sphere formula here. And then I'm also going to need the formula for a cylinder, which is, here's my cylinder, which is, make that a little better there. What do we got? V equals my pi r squared times the height. And my sphere is V equals 4/3 pi r cubed. All right, so let's take a look at this. Top of a silo is a hemisphere with a radius of 12 feet. So my sphere is going to be V equals 4/3 pi. It's got a radius of 12. So I'm going to do 12 cubed. And it's giving me radius, not diameter. So I'm going to do 12 cubed. And I get 1728. And I'm going to do 1728 times 3.14 because that's what they're asking me to use for that. I'm going to multiply that by 4 and then divide it by 3. And I'm coming up with 7234 point to the nearest tenth, 0.6. But I want to divide that by 2 to come up with the hemisphere. So I'm going to divide by 2, and I've come up with 3617.3. We'll call that. Now the cylinder, notice that they've given us 52 feet, but the 52 is from the bottom of the silo all the way to the top of that hemisphere that's at the very, very top of that. So I would really like to chop off the distance from the top of that hemisphere to its base. And if we think about if this was a sphere, the distance from the center of it to any outside edge would be the same. And we know the radius is 12 feet. So it's 12 feet from the center to any outside edge. So it's also 12 feet from the center of that, oh, that's hard to see, all the way to the top. So I'm going to chop off 12 here, and I'm going to say that the distance from the top to the bottom of the silo is 52 minus 12, which is 40 feet. So I'm going to use 40 in the volume of my cylinder one. So volume equals pi. Oh, my radius is still 12. Nice try, Ms. Mac. 12 squared, and then h is going to be 40. So I'm going to grab my calculator. I'm going to do 12 squared, 144. I'm going to multiply that by 40, 5760, and I'm going to multiply that by 3.14. So I'm coming up with 18086.4. So when I add these together, 3617.3 plus 18086.4, I've got 21703.7. What were we using here? Feet. Feet. And again, I'm filling this up with cubes. So it is cubic. There we go. So there we go for our finding volumes of composite figures. I'm just finding the volume of each of the pieces and then adding those together.